In this video, we will be learning about the different states of matter. The learning objective for this video is to describe the 4 states of matter. We will begin by describing the 4 states of matter in their macroscopic properties. That means what can you observe with your eyeballs. The 4 different states of matter are solids, liquids, gases, and plasma. We will be focusing mostly on the first 3 states of matter since these are the most common. The 4th state of matter, plasma, is uncommon. So we won't be focusing on that one as much. Plasma wasn't even really mentioned in Chem 3A if you took Chem 3A at Fresno City College. So we have this table over here to describe the 4 different states of matter. To start off with, we can start off by looking at the solid. Solids retain their shape. So it has a fixed shape and fixed volume. So we can say that that's definite shape and definite volume. It's defined by that object. It's also a very high density state of matter, meaning it has the atoms are close together and they're packed together very close. And then liquids are also a very dense state of matter. When you have a solid and you have a liquid, you can't compress them. You can't push the atoms closer together than they already are. And so that makes them higher density states of matter than a gas or a plasma. The atoms are close together. I'll just write that down. So the atoms are close together here and here, and then atoms are far apart for gases and plasmas. The difference between a solid and a liquid is that the atoms in a liquid are able to move past one another. And since they're able to move past one another, they are more free-flowing. And so they kind of take the shape of whatever container they're in. They do have, the volume is fixed though. So if you pour this liquid into a different container, it will take the shape of that new container, but it will have the same volume as it has now. So it will flow to fill the container in a horizontal surface, but it does have a fixed volume. Now, the gas, they can't just move past one another within that low area. They can move past one another and fill the entire container. So a gas expands to fill the entire container. But since the atoms are far apart, gases are compressible. And so that means that we're able to push on these gas molecules in order to push them into a smaller volume. And so since they are compressible, the volume is indefinite. That means it's not certain. This gas will expand to fill a larger volume, or you can compress it and then it will occupy a smaller volume. So gases don't have a definite shape, they don't have a definite volume, and if you look at the macroscopic properties of a plasma, they match that of a gas. Now, those were very large views of solids, liquids, and gases, but that doesn't really give you a mental image of what the atoms look like or how the atoms are arranged in those different states of matter. And chemists really need to understand what the structure of matter is on that atomic level in order to understand the macroscopic properties. So if you look at the atoms in that solid, you can see that they're in very nicely arranged patterns, and that's a more crystalline solid where they're arranged in a very nice way, but they can't move past one another. Even though it looks really rigid, they are vibrating. But they just can't move past one another. They are still moving though. Atoms and molecules are always in motion. Now, these ones in the liquid, they're able to move past one another. So you can imagine them moving around in different ways, whatever direction they're moving in. And so they are moving past one another as a liquid. In a gas, they are far apart, and so you can see them zooming around in this container. They have these kind of like light trails behind them just because they're moving so fast. But there's a lot of space in between them. So lots of empty space. If you would like to play with a simulation, on Canvas there's a simulation where you can see these different states of matter and kind of visualize them moving around and the atoms moving around. Now, if we look at the different states of matter for gas and plasma, we saw that they had very similar macroscopic properties in terms of their density and volume and shape. But they are different states of matter, and they have very important differences. Gases consist of neutral atoms and neutral molecules. And so here nothing is charged. Plasma, though, is made out of charged atoms, also known as ions. And that means that there's free electrons separate from the atoms or something that's creating them to be charged. It's overall neutral as a whole, but it's made out of ions and it's charged. Now, the differences between being something that's neutral and something that's charged creates a lot of other differences. For instance, to conduct electricity, you need charges. Electricity is the movement of electrons, and so since it's charged and you have these free electrons, it will conduct electricity. So since you have extra electrons or free-flowing electrons, it will conduct electricity. Gases are neutral, and so they do not conduct electricity well. Also, since they are neutral, the only intermolecular forces or between these gas molecules are dispersion forces, more on that later, but that's a very weak form of attraction. When you have charged particles, you have much stronger electrostatic attraction, so that's going to affect how they move. So these are very weakly attracted to one another. These are more strongly attracted to one another. We know that opposite charges attract and like charges repel. And so if you have a negatively charged ion moving towards a negatively charged ion, then this negatively charged ion over here is going to try to move away. And so you can get more collective motion happening within your plasma. And so that creates wave-like patterns when particles are pushing and repelling other likely charged molecules. So you get some wave-like motions. Also, since they're charged, you're going to have magnetic fields and electric fields playing a very important role in how that matter interacts and behaves. So gases and plasma are very different. These gas molecules, since they aren't charged at all and they're just not attracted to one another. They're just going to bounce off one another like billiard balls. So if you have this ball come in and it hits, then it's just going to bounce in whatever way physics says it's going to bounce. And so they just bounce off one another, but they actually like make contact. They don't like repel one another. They go pop and bounce off.